solve the question. In a class of 40 students, if you remember what I said about the universal set, 40 there is the universal set. That's the sum of all the students. I said that Venn diagram is a diagrammatic representation of sets. So we have something like a box this way, and we have this is the universal set symbol. Some textbooks put it like a U, like mu, those of you that take physics. It's either this or this. So the universal set is 40. 40, that is the sum of the total number of students in the class is 40. Now look at that. 32 offer mathematics, 24 offer physics, and 4 offer neither mathematics nor physics. What does that tell us? We have 3 subsets. Number 1 subset is the number of people that offer mathematics. We have the number of students that offer physics, and then the number of students that offer neither math or physics. Well, as we go forward, we'll find another subset. Now, let's go. We have a circle. We're going to represent the number of students that offer math and physics with a circle. So, let's use M for mathematics and P for physics. I hope this is clear. Now, look at the question. 32 offer mathematics. Now, what does that mean? The number of students that take mathematics, whether or not they take math and physics, but they attend mathematics class. So, the entire math subset is 32. Now, 24 offer physics. The entire physics subset is 24. But there is one here. 4 of them offer neither mathematics nor physics. So they are most likely not science students. So we have 4 of them here. We can only put the 4. So what do we do to the other ones? There's a question. The question says, how many offer both mathematics and physics? How many offer both mathematics and physics? Now here we go. This part of the diagram is for those who offer both. If you look closely, this is the intersection. This is what combines or what joins the 2 subsets, math and physics. So, and that is what we're told to find. So I'm going to make or represent that with X, the letter X. So how many students offer only mathematics? Note this. It is stated here that 32 of them offer mathematics. So if this number offers math and physics, the number that offers math alone would be 32 minus X. I hope that is clear. Now, whereas 24 students offer physics, so the number that offer physics alone would be 24 minus X. I hope this is clear. So if we have to take, if we add these 2 together, we're going to get 24. If we add these 2 together, we get 32. So we can work. So ideally, if we add everything inside this box, it will give us the universal set. That's why I said the universal set is all the sets, the sum of all the sets. So we have 32 minus x plus 24 minus x plus 4. This is expected to give us the total number of students in the class. So we can add that. Look at this. Minus x plus x will cancel out. That leaves us with 32 plus 24, which of course is 56, plus 4, which is 60. So I have 60. I still have a minus x here to give me 40. So I'll take my x out of here, over here, I'm bringing the 40 here. We can do it in 2 ways. Or I take my 60 over here and leave my minus x here. So if I take my 60 over here, it's always advisable to keep your unknown to the left hand side. I'm going to have 40 minus 60. So that is minus x equals to, 60 is bigger than 40, so that would be minus 20. If I divide both sides by minus 1, the minus will cancel out. I have x equals to 20, which is option D. The number of students that offer mathematics and physics are 20 students. I hope that is clear. Now let's go to the next question. Solve the following equation. Now this is a fraction problem. Very simple fraction problem. We can solve that question. Here we go. Fraction. Don't forget we're still on numbers and numeration. Solve the following equation. I have 2 over 2r minus 1 equals, minus 5 over 3 equals 1 over r plus 2. Now I'm taking pains to solve a lot of questions for you because it will be very easy if you can understand everything I'm doing here. I noticed something about 2020. Now in the year 2020, close to 20 questions were drawn from numbers and numeration and algebra. So you know what that means? If you know your numbers and numeration and algebra very well, you already got half of the marks. So please pay attention as we make progress. Now this is simple. We have fractions here. Fraction, fraction, fraction. So what comes to mind in solving fraction problems? LCM comes to mind. Lowest common multiple. Now when the denominators are not, when they are not alike, when they are not related in any way, the ideal thing to do when you want to get the LCM is to multiply both denominators. I'll give you an example. If I have 1 over 2 plus 1 over x, look at this. 2 is a number, x is a letter. The LCM would be 2 times x, that's 2x. So that's similar. Here we have 2r minus 1, and then we have 3. LCM here is 3 times 2r minus 1. Can you see this? Yes. Now we're dealing with this, the left-hand side of the equation. So if we do that, we have, how many of these can you find here? This will cancel out. We're left with 3. 3 times 2 is 6. Minus 3 will cancel 3. We're left with 2r minus 1. So that comes to multiply 5. We have 2r minus 1 equals 1 over r plus 2. 1 over r plus 2. So open the brackets. We have 6 minus 5 times 2r is 10r. Minus times minus. Please do not forget your signs. Minus times minus. Very many students will just quickly put a plus, or rather put a minus here, and say 5 times minus 1 is minus 5. No, but the minus will affect this minus. So minus times minus is a plus, and we have plus 5 over, when you multiply this, we have 6r minus 3, and then we have this equal to 1 over r plus 2. We can simplify this. 6 plus 5 is 11 minus 10r over 6r minus 3 equals to 1 over r plus 2. Okay, now let's go. Now this is actually a combination of numbers and algebra, as you come to find out. Let's make progress. Now we cross multiply again. We have 11 minus 10r times r plus 2. Let's put both of them in the bracket. 1 times 6r minus 3. Now, are you seeing something from here? It's taking us to quadratic equation. Now let's go. So I told you what to do earlier. Each term here multiplies everything you have in the next. So 11 times r is 11r. 11 times 2, there's a plus sign there, 22. Minus 10r times r is minus 10r squared. Minus times minus times plus rather is minus 10r times 2 is 20r equals 1 times everything is everything there. Now look at this. So we can collect like terms. Now before that, we have 11r minus 20r. That would give me, this is plus 11, this is minus 20. So you have 11, you owe 20. When you pay your debt, you're still going to owe. You owe 9. So this is 22 minus 10r squared minus 9r equals to 6r minus 3. So bring everything here so we can have 0 at the other end in an attempt to solve the quadratic equation. This is already quadratic. You can see the highest part of the variable here is 2. So now we have collecting like terms 22 minus 10r squared minus 9r minus 6r plus 3 equals to 0. Do not forget, this is plus 6, it comes over here, it becomes minus, this is minus 3, it comes here, it becomes plus. So we still have a lot of things to do. This can work on this can work on this. So I'll have to work on this side of my board, and then I have 22 plus 3 is 25, and then minus 10r squared, minus 9 minus 6 is minus 15, minus 15r. Now for simplicity, I'm going to change all the signs. And how do I do that? If I move everything here to the other side, all the signs will change. So it becomes 10r squared. I said for simplicity, it makes the work easier if you have a chance to make your r squared positive. It makes the work easier. Plus 15r minus 25 equals to 0. Now this is a quadratic equation. I'm going to teach you more of quadratic equation when we get to the algebra part of this class. Now what do we do? Bring these two last numbers together, not forgetting the signs. 25 times 10 is 250. There's a minus here. R squared is here. I'm going to split this open. I have r here, and I'm going to look for two factors of 250. Okay, that if I add them, I'm going to get plus 15r. Good. So if I have 250, now the work is actually made simple for you here. If you look very closely, I have 10, I have 25. 25 and 10 are two factors of 250. If I work on this, I can get 15. If I have plus 25 and minus 10, I'm going to get plus 15r. So this is 25 and this is minus 10. That gives me 15r. Take note of that. Now, I need to teach you something, but when I go to algebra proper, you'll understand. Now, what's the next thing to do? I'm going to replace this middle number with these two. So I'll bring this down here. I'll bring this down. Okay, all I have here, 10r squared. Now, instead of 15r, I'm going to put these two numbers. So I have plus 25r minus 10r, and then I have minus 25 equals 0. Now, I am going to pair the numbers. What does it mean? To pair means to have two, right? Two pairs, two. So I'll pair the numbers. I have four numbers here. So I'll pair them. So I have two pairs. So I will factorize two pairs. Please take note. This formula or this method of solving quadratic equation that I'm using here is called factorization method. That's where it got its name from here. If I factorize. Now, what is common to these two? Of course, you can see there's an r. 5 is also common. So if I have 5r, I'll be left with 2r plus 5. Now, take note of this. Whatever we have here, we can always go back here when we multiply. 5r times 2r. 5 times 2 is 10. R times r is r squared. 5r times 5 is 25r. So this is what I have. 5r, and then we have 2r plus 5 in the bracket. Now what is common to these two? 5 is also common. Minus 5. I beg your pardon. Minus 5. And I'm left with 2r plus 5. Now take note of this. When you're solving quadratic equation using factorization method, if these two are not the same, something is wrong with your solving. Now let's go. So we bring these ones outside in the bracket and we pick one of these two brackets. So we have 5r minus 5 2r plus 5 equals to 0. So 5r minus 5 equals to 0, or 2r plus 5 equals to 0. So make r the subject of the formula here. I have 5r equals to 5. If I divide both sides by 5, my r becomes 1. Here I have 2r equals to minus 5. If I divide both sides by 2, my r becomes minus 5 over 2. This 5 will cancel this 5 will cancel this, 2 will cancel this, we have this. So our answer is 1 and then minus 5 over 2. That is option B. 1 and then minus 5 over 2. I like mangoes. 3 children shared a basket of mangoes in such a way that the first child took a quarter of the mangoes and the second 3/4 of the remainder. Please take note of that. I think that's just common sense. If the second child took 3/4 of the mango, there will be nothing left for the third child. But no, he took 3/4 of the remainder. Now this is a word problem question, and I'm going to teach you how to solve that. The question is, what fraction of the mangoes did the third child take? What fraction of the mangoes did the third child take? Now let's solve that question. Very simple question. Very, very simple question. We got that from 2020. I didn't tell you that. Of course, please, for all the questions I've solved, at the lower part here, the lower right hand part of the board, you'll find the year and the question number. So you can always make reference to that. Now let's go. We don't know the number of mangoes that is shared. So let the number of mangoes be x. Very simple fraction question. Now, one child, or the first child, took a quarter of the mangoes. Of mathematics is multiplication. So 1/4 times x. Now if you do the math, you have x over 4. This goes to the first child. Now, if he is taking x over 4, what is left? That's a big question. What is left? Now, how do you find what is left? This is the total mangoes that we have. He has taken x over 4. If you do the mathematics, this is 4. The LCM is 4. What do I have here? 4x minus x. This gives me 3/4 of x. I think that's even easy. If someone took a quarter, what is left is 3/4. So 3/4 of x is what is left. What is left? Now the second child took 3/4 of that remainder. So I can write what is left or remainder. Second child took 3/4 of the remainder. Remember, the remainder is 3/4x. So remember that of in mathematics is multiplication. So 3/4 times 3/4x. 3 times 3 is 9. 4 times 4 is 16x. Now, this is what the second child took. Hey, the question is, what is left for the third child? Please listen. Now, remember the second child took 3/4 of what is left. Now, the two other children are sharing from what is left. What is left is 3/4. What has gone to the second child is 9/16x. So how do we get what goes to the third child? Simply subtract what the second child has or took from what is left. So that is 3/4 minus, x, if you like, minus 9/16x. So LCM is 16. Now you can actually put the x aside. It's just a fraction that you need to find, so you can do without the x. Okay? Now it's just a fraction thing, but it's okay if you have the x there. Now the LCM is 16. You can find 4 4 in 16. So that's 4 times 3 is 12. So 12x minus 16 is 16 is 1. 1 times 9 is 9. 9x. So you have 3 over 16. So 3 over 16, what fraction of the remainder? Remember that the remainder, what fraction of the remainder did the third child take? 3 over 16 is the answer. 3 over 16. That's the fraction that the third child took. Now, this is very simple. It's simplified and has to be standard form. Well, I think you should be able to solve this question because we've solved a question like this before. But like I said, you can take a pause the video at this point, solve the question, and see if you're correct. I'm going to solve it very quickly. We'll solve a similar question, so I will not spend too much time on this question. So you can solve the question, and when you're done, press play and see what I got. 0.00275 times 0.00640 over 0.025 times 0.08. Alright, so I have 275 times 10 raised to the power minus 5 times 64 times 10 raised to the power minus 4 over 25 times 10 raised to the power minus 3 times 8 times 10 raised to the power minus 2. Now, of course, you know what I mean. I move the decimal point, the number of places that we have quoted here. It makes the work easy for me. Now I have 8 can go in 64, 8 times. You see this? Good. 25 can go in 27. Do you know how many times? You want to try? You can break it down, make it easy for you. 5 here is 5. 5 in 27 is 5. In 25 is 5. You see that? So 5 here 1, 5 here 11. So if you multiply both of them, you're going to have 11 times 8 is 88 times, now let's deal with these powers. I taught you that in indices. Minus 4 minus 5 is minus 9. Minus 3 minus 2 is, you know, what we have down here is 1, right? 1 times 1 is 1. 1 times 10 raised to the power minus 5. So this is 88 times, don't forget, 88 over 1, let's deal with the like terms. 10 raised to the power minus 9 divided by 10 raised to the power minus 5. Second law of indices. So this is 88 times 10 raised to the power minus 9. The division sign makes this minus 5. So this is 88 times 10 raised to the power minus 9 plus 5. You owe 9, you have 9. You pay and you still owe 4. 88 times 10 raised to the power minus 4. Because we're told to give the answer in the standard form, take note of this. 88 is simply 8.8 times 10. Take note of that. Times 10 raised to the power 1. If you have times 10 raised to the power minus 4, from what I taught you so far, this will be 8.8 times 1. You have 1, you owe 4. It means you owe 3. 8.8 times 10 raised to the power minus 3. 8.8 times 10 raised to the power minus 3. Well, back to our option C. The correct answer there is option C. This is solved. This is logarithm. And that will be the end for numbers enumeration. Let's quickly solve this solved question. We won't spend time here. Very, very quickly. We have solved. Now, ideally, I'd like to give you, I decided to give you more than one question for each subtopic under numbers enumeration. So it will help you when you want to solve. Now we have simplify. To simplify means to make simple. To simplify, to make simple. 27 root 27 plus 3 over 3. Now this is very simple. Here we go. Here we go. This is a fraction. This is not a fraction. To make the work easy for you, make this a fraction so we can find the LCM. LCM of 1 and root 3 is square root of 3. How many 1 can you find in root 3? Is root 3. So we multiply. Now let me give you one law of sort. Look at this. Now root AX times root Y is root xy. Take a look at that. That's a lot of sort. With x times root y is root xy. Now we're going to take a break at this point. When we return, we'll continue and we'll see how to solve the question. Stay tuned.